Hello, I'm Jack. Welcome to my YouTube channel, Practical Programming with Dr. Su. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to map an image texture onto the surface of a 3D object. In this video, I will explain how to use this texture framework built in our texture.ts file to create a 3D textured cube. In order to create the textures, I have added 9 images to the DRST assets folder. These images have the same size, 512 by 512 pixels, and have same PNG format. Here are 9 images, including Jiuzhaigou, Sichuan Province, China, Grand Canyon, and Earth, New York City, wood, Yellowstone, grass, brick wall, and marble. Of course, you can also use your own images for the texture mapping. The texture coordinates for the cube can be easily generated. Here are the vertex coordinates for this cube. Let's consider the front face A, B, C, D as shown here. This front face can be divided into 2 triangles ABC and CDA. Here we will use 2 variables UL and VL to set up the upper limit of the texture coordinates. It can be 1 or less than 1 or greater than 1. Their default value will be 1. Here are our texture coordinates for this front face. The A point is T00, a B point is UL0, and the C point is UL and VL, and D point is 0 VL. For our triangle ABC, we have 3 text coordinates. This A is 00, B is UL0, C is ULVL here. For triangle CDA, this ULVL, 0VL is D, and 00 is A. With this procedure, we can also easily create a texture coordinate for other faces of our cube. Here, we will use the Git tool to clone the source code used in the last video. Here is the download link at the GitHub repository. From this link, you can download the source code used in the last video. Now, open a command prompt window and run the following command: git clone, paste this link. This will generate a WebGPU 33 folder on your local machine. This folder contains all the source code used in the last video. Now we want to change the name of WebGPU 33 folder to GPU 34. Rename WebGPU 33 to GPU 34 and cd into it. GPU. At this point, we are going to start Visual Studio Code with the command code period. This is Visual Studio Code interface. Okay, we can close this welcome page. Here contains all the source code used in the last video. Now open a new terminal window and run the npm install command to restore the npm packages used in this example. Okay, finished. Now all the installed packages are stored in Node modules folder. Now we need to generate the text coordinates for our cube. From the src folder, open the vertex data cube.ts file and found the cube data function here. Cube data function. Here we will use two variables ul and vl to set the upper limit of the text coordinates as mentioned previously. So here we set the input argument ul equal to 1, vl equal to 1. Input argument set its default value equal to 1. Then we need to add the UV data here with the new code. We already discussed how to generate these text coordinates for our cube previously. This is our UV data for our cube. Here we also need to return this data, UV. So now we finish the modification to this file, so we can save this file and close it. Next, we need to make some changes to the index.html file. From dist folder, open index.html file. First, we need to change the 32 to 34 because this is 34th video. Another place we need to change is h1 title here. We need to change to cube with texture. Input parameter we also need to change. So with the new code, you can see here is select image. So we already set up the 9 different images. You can select the image from here. And also you can set U length UL, the V length VL, and address mode U and address mode V. So now we can save this file. Next, we need to make some modifications to the min.ts file. From src folder, open min.ts file. Here we need to replace this code with a new code. You can see first here we introduce create a shape with the texture function from the texture.ts file. And also we introduce the cube data method from vertex data.ts file. Inside this create a shape function, we first call the cube data method to get vertex position and normal vector and UV data, and then we call create a shape with texture method to generate the text mapping for our cube. Here we set default input parameters. You can see here the text file we use break.png, and the address mode U and V we set as a repeat. Of course, you can set other options such as mirror repeat or climb to edge for this address mode. And also we set UL equal to 1 and VL equal to 1 as a default value. We then call create a shape to generate our cube with default parameters. The rest code here is used to regenerate the textured cube with the input parameters specified by the user. Now we finish the modification to the min.ts file, so we can save this file. Up to now, we have finished all the programming. Now we can run the following command on the terminal window to bound our TypeScript code in production mode. npm run prod to bound our TypeScript file. Okay, the bound file is generated successfully. Now we can click the Go Live link from the status bar area to open the Chrome Canary to view our cube. So click this link. Here is our textured cube with default lighting and texture displayed on this page. From this drop-down menu, you can select different images. For example, it's the earth, the grass, it's the Grand Canyon, it's Jiuzhaigou, Sichuan, China. This is a marble. This is New York City. This is the wood. This is the Yellowstone. So let's go back to default break. Now we can change the U length and V length. This is UL and VL. For example, we can change it to 0.5, less than 1, 0.5. This is because it's too many breaks. We just use a quarter of the image. So redraw it. You can see this looks nicer. Okay, we can also change it to greater than 1. For example, change it to 2. See the more breaks. You can change to New York City. There is a problem. You can see the transition not very smooth. You can see the line here and here. So to remove this line, we can use mirror repeat. Mirror repeat. So you don't have this transition line because it has a mirror. You see, it's smooth and also smooth here. This both direction, U and V direction, we use mirror repeat. So this looks nice, a smooth transition. Now we have completed this example. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.